So if you look at the sine function, it is a continuous wave going on forever both directions. It is a function. It passes the vertical line test. Just like I said, when I said, what is the sine at pi over 3, you can give me an answer. There's only one answer there. But if I reverse it and say, what angle has a sine of 1/2, you could give me an infinite number of answers. So it technically is not a function unless we restrict it. So we're going to restrict the function just to this little piece. Okay? If I just looked at that piece, it passes the horizontal line test. For every x, there's only one y. So we're going to restrict it. Just like we restrict the x squared function so that its inverse square root is a function. Okay? So the range of sine inverse, the type of answers you can get, is from negative pi over 2 to positive pi over 2 on the right side of the circle only. So it's restricting the answers you can give. So when you see sine inverse, the only kind of answers you can get are negative pi over 2 or negative 90 to positive pi over 2 or positive 90 if you're in degrees. The domain is the negative 1 to 1. You can't do the sine inverse of 2.6, for instance, because there's no angle that has a sine value of 2.6. Sine values do not get higher than 1, and they're not lower than negative 1. Okay? So, if I ask, what is the sine inverse of rad 3 over 2, I'm specifically saying on my circle, so let's look, I'm going to move this circle out a little bit. On this circle, what angle has the sine value of rad 3 over 2? So that's long, so I'm going up long, and there's technically on the unit circle 2 angles that have the sine value of rad 3 over 2, but which one do I want to have as an answer? This one over here, right? Pi over 3. Or 60 degrees. Because the range of answers that are allowed is between negative pi over 2 and positive pi over 2. So this one over here doesn't count.
I thought the cosecant was like the inverse of sine.
No. Cosecant's the reciprocal. There's a difference between reciprocal and inverse. Reciprocal is just 1 over. Inverse is, when I say what's the sine of pi over 3, you're giving me a fraction. When I say what's the sine inverse of the fraction, you're giving me the angle.
Okay.
So sine inverse, I'm getting angles as answers. When you say sine, you're giving me the fraction of the distance as an answer. Okay? That's the difference. All right? Now, the other part of this. Let's change this for a second. Let's make this a negative rad 3 over 2. Okay? So here's my circle. I'm going down negative. And again, there's 2 angles down here. I only care about the right side of the circle. So I'm only going to look at this angle here. What is that angle? 300 degrees, right? Or 5 pi over 3? Is that within the range, though? The range is from negative 90 to positive 90. So I can't say 300 degrees. It's not in our range of answers. So what's another angle I could say? Negative 60. So if you are in this 4th quadrant, the angles have to be a negative angle. It has to be negative 30, negative 45, negative 60, one of these. Okay? So you would say this is a negative pi over 3 or a negative 60. Does that make sense? So if you're doing the sine inverse of a negative number, you're going to get a negative angle. All right? Cosine inverse. It's restricted a little differently, because if I restricted it from negative pi over 2 to positive pi over 2, my problem has not been solved. Okay? So I have to restrict it from 0 to pi. So I'm at the top part of my circle. Only care about answers up top. So cosine inverse of 1/2. So I'm going to go to the right 1/2. I'm going to be at this angle or this angle. And again, I only care about the one at the top between 0 and pi. What angle is right here? Pi over 3. Make sense? Okay. The domain is the same. It's between -1 and 1, but the range is different, 0 to pi. All right. Tangent inverse has the same restriction. The asymptotes is restricting it, so it's really easy to see. -pi/2 to pi/2. It's the same restriction as sine, except it doesn't include the endpoints. Tangent doesn't exist at pi/2 or -pi/2, so those are undefined. Open circles on our graph. They don't include it. And the domain of tan inverse is all reals. You can take the tan inverse of any number you want. It's not bound between -1 and 1. All right?
What's arctan?
Arctan and tan inverse, same thing. Just another way of writing it. When you see that word arc, it just means inverse. That's a good question. Because it will come up. Half the questions will say arc and half will say inverse. Okay? So if I said inverse secant, that's the same as reciprocal of inverse cosine. Inverse cosecant's reciprocal of inverse sine. So they're in the same location of the circles. But tangent and cotangent inverses are in different parts of the circle, so it's kind of weird. So sine inverse and cosecant inverse are both in the first and fourth quadrant, right side of the circle. Cosine and secant are both in the top part of the circle. Tangents on the right, cotangents on the top. Just think of the cotangent asymptotes. They're between 0 and pi. That's where their asymptotes are. Okay, so sine, cosecant, and tangent are all on the right side of the circle. Cosine, secant, and cotangent are on from the top of the circle. You can memorize quadrants if you want, it doesn't matter. Remember, if you're in the fourth quadrant, though, negative answers. So let's see how many of these we can do. I'm waiting. All right, sine inverse of 1/2. So think of the right side of the circle. What angle has the sine of 1/2, Ryan?
Pi over 6.
Pi over 6. Okay. Think of the circle cosine inverse of negative rad 3 over 2. So it's always kind of, doesn't hurt to just draw the circle. Cosine is long, negative rad 3 over 2, top of the circle. What is this guy? 5 pi over 6. Arctangent. Arctangent. I'm hoping you start remembering these tangents because that's easier than doing the dividing. Tangent, rad 3 over 3 is here. The negative one is going to be here. So what angle is that? Pardon? Negative pi over 6, not 11 pi over 6. Remember, it has to be negative down in that quadrant. Arc sine of negative 1/2. So sine is negative 1/2. Oh, we're in the same angle. What is that again? Negative pi over 6. So you arc?
Is that just cosine?
No, it means sine inverse.
Oh, sine. Okay.
Right? Arc is the same thing as inverse.
Can you explain the tangent thing again? Like how you got it?
I would just know my tangents because it would just be easier. In the first quadrant, your tangents run like this. Rad 3 over 3 is the smallest one. 1 is always in the middle, and then you have rad 3. This is 0. This is undefined. Okay? I would just know those. And understand that if it's close to the x-axis, it's going to be a rad 3 over 3, and they alternate signs, positive, negative, positive, negative.
So, and because we're in the fourth, you have to go negative.
You have to go negative angle.
5%.
Yep. Okay?
Yeah.
All right. So, when you're doing composites, so this is the sign of the sine inverse. So when you're doing composites in this order, trig function, then inverse trig function, it always, always, always equals whatever you put in there, as long as it's defined. So whatever is here is going to equal whatever it answers as long as it's defined. What do I mean by that? Well, let's do some examples and see. Is there an angle that has a tangent of rad 3 over 3? Isn't tangent inverse always defined? Because the domain is all reals.
Yeah.
So the tan in tan inverse is always, always, there's no restrictions on it. It's going to be rad 3 over 3. Whatever you have in here is going to be the answer. Automatic for tangents. Automatic. Okay? We're taking the tangent of the tan inverse.
So they cancel out.
They cancel out. Yes. Let's try this next one. What is the sine of the sine inverse of 1.2? 1.2 is not in the domain. Remember, what is the domain of sine inverse? Negative 1 to 1, right? So it's not, it's undefined. So it does not equal 1.2. It doesn't equal, you can't do it. The sine inverse of 1.2 is undefined. This is not possible.
So it's none.
You just say it's undefined. It is undefined. Okay? You understand? It automatically equals what's in here as long as it's defined at that number. Cosine inverse of 1/2. Is 1/2 within negative 1 and 1?
Mm-hmm.
Yes. So the answer here is going to be 1/2. Okay, so if you want to kind of see a step-by-step demonstration of what the heck they're even talking about, let's do this. What angle from the top has cosine inverse 1/2? What angle has cosine 1/2? This guy right here? Pi over 3. So then they're saying, what's the cosine at pi over 3? Well, it's 1/2. We just got done saying that. See what you're doing? You're saying, what's the angle that has a cosine of 1/2? And then you're saying, what's the cosine of that angle? Well, it's obviously still 1/2. We didn't do anything. That's why it's the same as long as it's defined. There is no angle that has a sine of 1.2 because that's impossible. It's outside of its domain. Okay? All right. If we look at composites the other direction, when we have the inverse and then the trig value, it's sometimes true, depending on if you're in the correct part of the circle. But if it's not true, you can find it. So, is pi over 9 between negative pi over 2 and positive pi over 2? Is 1/9 between negative 1/2 and positive 1/2? Yes. So this just equals pi over 9. Because the angle that they gave you is within the range of the sine inverse. So you're done. Okay? Cosine 5 pi over 3. Let's see where 5 pi over 3 is. 5 pi over 3 is here. Is that between 0 and pi?
No.
No. So if it's cosine inverse, doesn't that angle have the same cosine as 5 pi over 3? Yes. What is that angle? Pi over 3. So in steps, what they're saying is, what's the cosine of 5 pi over 3? We would say, oh, that equals 1/2. And then you're saying, what angle from the top has a cosine of 1/2? And then you would say pi over 3. But that's just basically a reflection. So you have your circle reflected. Tangent, 5 pi over 4. So the tan inverse of the tangent at 5 pi over 4. 5 pi over 4 is here. What is the tangent at that angle? This equals 1. So we need to be on the right side of the circle. We need an angle from the right side. Do I go straight across? Is the tangent here also 1? No, it is -1. But this angle has a tangent of 1. So instead of going straight across horizontally, I'm going to go diagonally. So tangent has to go diagonally because it's every other quadrant that they're the same side. Okay? All right. Let's do this guy. 5 pi over 6. It's right here. Is that on the right side of the circle?
No.
No. What angle has the same sine value, same height? No. Pi over 6. See how we're doing this? We're just putting them in the correct part of the circle. Or you can always answer them 2 different places. This guy here, you have to just do the composite. What is the sine at 7 pi over 6? What's the sine at 7 pi over 6? -1/2. Now we're saying, what angle has a cosine of -1/2? That's at the top of the circle. 2 pi over 3.
I don't know which part of the circle it's going to be.
Sine and tangent are on the right side. Cosine has to be on the top. That's what we talked about. Those in here. See how cosine's on the top, 0 to pi? Sine and tangent are both -pi over 2 to pi over 2. Okay? So those are composites. Okay, let's try this composite. These are not unit circle angles, so we have to use a triangle. So the sine is -1/3. What does sine equal? SOHCAHTOA, what's sine equal?
-1/3.
Yep. Is it SOHCAHTOA? What sides is it? What side?
Oh, wait. Yeah, I have no idea, honestly. Oh, is that what you're asking?
Yeah, that's what I was asking.
Yeah.
Okay. So opposite of hypotenuse. So the -1 is the opposite side, and the 3 is the hypotenuse. So draw your circle, or draw your triangle. You've got your theta, mark one of them. Opposite side, hypotenuse. Hypotenuse is always positive, never negative. Okay? What would my third side be? What would this guy be? Square root of 8, which is 2 square roots of 2. So now what is the tangent of angle theta? Opposite over adjacent. Okay. So you're going to lay out your triangle, whatever the trig function they give you, write the fraction out using SOHCAHTOA, lay your triangle sides out, find your missing side, and then answer the question. Pardon? That's the answer. Okay. They actually asked for all this. I changed the question. I forgot to reduce this. All right. Let's try another one. Okay, write an algebraic expression for the y equals cotangent of the sine inverse of 3x over 5. So you guys go ahead and fill out your triangle. See if you can find the third side. Okay, our third side is 25 minus 9x, square root of that. Can you reduce that to 5 minus 3x?
No.
Nope, nope, nope. Resist the urge. I know it seems like it should be that way. But think of it this way. 36 is a perfect square, right? Minus 25? So if I did that, if I said 6 minus 5 is what that equals, that equals a 1. Yes? Is that what the square root of 11 equals? No. Just because two numbers are perfect squares, that doesn't mean the difference is a perfect square. So you can't do that. So just leave it in the ugly square root form. So now I'm saying, what is the cotangent of that angle? Cotangent is adjacent over the opposite side. And you would just leave it like that. Okay? Crazy, crazy. All right, we have one more slide. Okay. All right. Word problem, see if you can do it. I'm pausing, letting you do this. Okay, so they're going to have some word problems where you have to use some Sopatella, set them up, and find the angles. You always do inverse. You look at angles. Okay. All right.